Hello, we're Team CE2. Our project is a soil nail wall post-construction analysis. Our team members are Liana Santos, Catinho, David Puentes, and Juan Casareto. Our sponsor is Michael Madonna with the Connecticut Department of Transportation. The Connecticut Department of Transportation constructed the first permanent soil nail wall in 2002 to provide lateral earth support for the excavation below an existing perch abutment. As this was their first permanent soil nail wall, the design was very conservative and did not account for soil arching between the H-piles supporting the abutment.
The deliverables for this project were digital design for existing soil nail wall, comparison of snap loads to instrumentation and hand-calculated loads, method to manipulate snap software to reflect soil arching, educational video about soil arching, and soil nail wall software survey. Soil arching occurs when there is a difference in the stiffness between an installed structure and the surrounding soil. This allows the pressure applied to the surrounding soil to be transferred to the installed structure, the H-piles. Soil arching between piles increases the lateral load on the piles and decreases the lateral load on the structural members, in this case the soil nails. The Connecticut Department of Transportation did not take into account soil arching between H-piles when they designed the soil nail wall. Our group compared the actual tensile force in the nails measured by instrumentation to a tensile force calculated by SNAP and the original hand calculations. We found that the SNAP and hand calculated loads were much higher because they did not consider soil arching.
The major design goal for the project was to model the soil nail wall using SNAP and modify input parameters to mimic load reductions that occur due to soil arching. Our goal was to generate a nail tension distribution that was more similar to what was measured by the instrumentation. To accomplish this, we needed to lower the values of Tn and Tf. Lowering these values mimics lowering the force of the soil on the shotcrete facing and therefore the force on the soil nails. We had two alternatives for modeling soil arching using the SNAP software. Adjusting the loading on the wall did not work to lower the nail tensile forces. We learned that there was no change in the tensile forces because they are based only on material properties, not limit equilibrium loads. The tensile forces generated by SNAP and through hand calculations are allowable loads, not actual loads. Our second alternative involved changing the material properties of the nails and facings. We found that reducing the diameter of the nails lowered the Tn force to make it more similar to what was measured by instrumentation. Changing the properties of the facing materials did not change Tf as we expected them to. The tensile forces generated by SNAP are maximum allowable loads for the steel nail diameter, not the loads generated by the earth the soil nails support.
Based on our results, the instrumented values of Tn and Tf are lower than those calculated by SNAP and by hand because soil arching reduces load demand on the soil nails. The algorithm in SNAP that calculates the values of Tn and Tf are based only on material properties and don't take into account the soil arching effect or any manipulation of the loads imposed on the wall. While reducing the nail diameter did reduce the Tn force, a future soil nail wall will have to be constructed and instrumented to determine how much of a reduction in diameter is possible. This means that SNAP inputs cannot be manipulated to mimic load reduction due to arching during the design of the wall. This can only be done after construction, when data is downloaded from the instruments. If the Connecticut Department of Transportation wants to take advantage of the soil arching effect and develop more cost-effective soil nail designs in the future, they should evaluate other software products. A profitable software package will offer the capability to manipulate the loading inputs that mimic soil arching and will provide an output where reduced nail tension values can be calculated that more closely resemble instrumented values. We complete a soil nail wall software survey and recommend that they look into several programs.